I'm Kevin Miller, I'm RunRev CEO, and with me today is Eleanor Buchanan, who's one of our senior engineers here at RunRev. I'm going to run through a short introduction, then I'm going to hand over to Eleanor, who's going to present today's topic. Today's webinar is an hour long. Please type in questions at any point and we will answer them at the end. For those of you that are completely new, I'm going to run through what LiveCode is and why people choose LiveCode. I'm then going to run through what you can expect to learn throughout this 7-week course and tell you how this course is structured. We have a real mix of people in the audience today, both seasoned mobile developers and people looking to develop their very first mobile app. But most of you are brand new to the LiveCode platform, so I thought I would spend a few minutes outlining the core benefits of the platform, covering both what LiveCode is and why people choose it. LiveCode is an integrated development platform that makes it really easy to create great cross-platform mobile applications. We've had tremendous interest in the platform since we launched the iOS deployment pack back in December and the Android deployment pack just last month. Mac User Magazine gave us an Editor's Choice Award. They said, "Whatever software you want to create, LiveCode makes it possible. LiveCode is a truly exciting product. You can make your own software without alien programming that runs practically anywhere and does practically anything." And DevPro Connections said in their comparison of mobile platforms, "Creating programs that take advantage of hardware features is fast and straightforward. If I had to pick a favorite among the products highlighted in this article, I'd cast my vote for RunRev's LiveCode." There are 3 core benefits to the LiveCode platform. The first is the compile-free workflow, which allows you to achieve your project goals in a fraction of the time. This is a traditional development cycle, and a lot of you will have spent a good proportion of your day perhaps developing an app using this cycle. And you're probably very familiar. You go out and you edit your application and compile your application, you run it, you debug it, and you go right back around to the start again. That's quite a time-consuming process. LiveCode replaces that with a very simple edit and run cycle, so you're iterating over your application. Your application is always running as you're creating it, so you can make small changes. You're that much closer to the metal. You don't have to think about making a big change and then trying it out. And it really shortens the process of developing an application. We also have our English-like concise language, which allows you to write code that makes sense. So here we have a common programming problem. I want to sort the lines of this comma-separated text by surname in reverse alphabetical order. So in this example, I've got Mr. Kevin, Miller. I want the surnames to get sorted, so it would be Waddingham, Nagy, Miller, and Beaumont. Now, in LiveCode, all you have to say to accomplish that is sort lines of the text descending by item 3 of each. So each item is a block of text separated by a comma. And if we run that code, we get exactly what you would expect. The text is sorted. Now if we compare what you have to write in order to get this done in JavaScript, it really is a lot more complicated. Not only is it many more lines of code, but each of those lines of code contains a number of symbol characters. They have to be very precisely laid out. There's a lot of scope and a lot of potential for error. And it's a very similar story in PHP. And of course PHP is very different, so it has a different syntax to JavaScript, so if you need to deploy a web application, then you might have to learn both languages. And finally, if I want to compare this very same sorting function, what you'd have to do this in Java, remember that Java is the language for preferred for Android development, and if you want to deploy to iOS as well, then you also have to learn ObjectiveC, which is another very complicated language that's similar to Java. So these languages all have their strengths, but LiveCode has an advantage, making it really simple and really quick to get things done. The other really big benefit of LiveCode is that you can write once and deploy everywhere. You can deploy your application to iOS, to Android, but also to the Mac, Windows, and Linux desktops, to servers, and to the web. So here's a summary of developing a cross-platform application. You have your traditional application development cycle, which is replicated 3 times if you want to deploy it to iOS, Android, and Windows. So you have to go through the traditional edit, compile, run, debug cycle on each of those platforms. And you have usually three different languages to get the job done. In LiveCode, it's a fast, iterative development cycle. It's a single language. You write a lot less code, and you deploy to all of the platforms at once. We created this infographic called the Smart Mobile App Developer's Journey, where we did research from our customer base into what the key drivers are and how to develop and deliver a really great mobile application. So you start out by choosing the right mobile platform, and we've got the key drivers for choosing a delivery platform here. The current customer base on the platform obviously comes first. That's the size of the market. Then things like the active developer community and whether or not you know how to develop for that platform. Then we have direct revenue potential and large market penetration. It goes right the way down to things that are really unimportant, like everyone else is doing it. We then asked which mobile platforms are important, and iOS came out at a little bit over 90% when you add up extremely important and very important. Android came out at around about 70%. The other platforms are really also rands, certainly at the moment anyway. You then go on to designing your application. And the old saying, measure twice, cut once, couldn't be more appropriate here. Investment spent on design is always time well spent. Design your app's user experience step by step, getting feedback from the customer or real user at every stage. Make it stunning. Get it right before you can commit to costly implementation. It's really important. If you get the user experience of your application wrong, and nothing else really matters. And that's one of the areas that LiveCode can really help, because by being able to have this iterative development process and create real-time prototypes, you can reduce design errors, you can get your content and your interface and your user experience into the hands of your target customer or your target users before you commit to costly implementation. And design failures, they cost around about 10 times as much to correct once you're into the implementation process, and 25 times as much after the product has been launched. So we then go on to implementation. Choose a smart development tool. LiveCode allows you to develop simultaneously for Android and iOS, and LiveCode customers told us that projects were completed in less than half the time. So an average saving for a customer choosing LiveCode was $38,000 per project. And obviously it ranges very much depending on the size of the project, but it goes from the cost of a flight from Boston to New York right up to the cost of sending a family into space on Virgin Galactic, so a saving over $2 million. And this comes from research from our customer base. We asked our customers what tools they would use and what alternatives they would choose if they weren't, for some reason, able to use LiveCode for a project. And another really interesting thing that they told us was that 38% of projects undertaken in LiveCode would not have been commercially realizable in another tool. So you get on to the end and you're ready to sell your application. Well done. The apps market is valued at a staggering $8.8 billion this year and $17.5 billion next year. So absolutely runaway growth going on at the moment, and it really is growing faster than virtually any other platform that's been introduced recently. So as I mentioned, we've had a huge amount of interest in the platform, and people keep telling us, I want to learn how to do this. So we've created this Summer Academy, and we're going to take you right from the basics all the way through to being able to create a sophisticated mobile application that runs on both Android and iOS. So I've got the course schedule here, and in week 1 we're going to be covering basic coding. We're then going to go on and talk a bit about building user interfaces and how to create mobile interfaces. We're then going to talk about how you manipulate text and data, something that most applications have to be able to do. And then talk about some mobile fundamentals, accessing device-specific features and designing your application to take advantage of mobile devices. We're then going to move on and cover multimedia concepts and layout and user experience using databases, which is critical for creating cloud and client-server applications. And then finally, we're going to talk all about everything that you need to know when it comes to deploying to your device. So the webinars are going to be held at 5 o'clock British summertime each week, which is 9 AM Pacific and noon Eastern, and they'll run for an hour. So at the end of the course, you will be able to create a complete iOS or Android app. You'll have learned all about iOS Android app design principles. You'll have learned transferable best practices. A lot of what you're going to be learning here can be used regardless of the development platform that you need to use, particularly things when it comes to designing a great user experience for a mobile application or getting the interface right. You'll have learned the basics of programming if you're a complete beginner, and you'll have learned the LiveCode platform if you're a professional developer switching from another tool. You'll have learned intermediate and advanced concepts, become efficient with LiveCode, and of course improved your overall programming skills. So that's the goal for this 7-week course. So I am now going to hand over to Eleanor Buchanan, who's going to present today's topic.
Thanks for that, Kevin. I'll just introduce myself again. Kevin's already done it, but I'm Eleanor. I'll be your lead trainer over the next 7 weeks, and we'll be taking you from the very beginning, the very basics of LiveCode, all the way through to the creation of a completed application that runs on iOS, Android, and the desktop as well. It's a completely cross-platform development environment, so it should run equally well on all those platforms. So first things first, we will assume that you all have LiveCode already installed. So we'll get it started up, and we'll take a quick tour of the LiveCode development environment, which we sometimes refer to as the IDE, or Integrated Development Environment. So this is what you'll see when you first start up LiveCode. This is where you'll be spending most of your time if you're developing your application, and we'll just have a look at the different features, the different sections of the LiveCode development environment, and then we'll get started on discussing the structure of LiveCode applications, the methodology behind how they work and interact, and we'll actually make a couple of small applications today as well. So you can see here in the center we have the LiveCode Start Center. This shows up when you first open LiveCode, and it's just a nice way of finding your way around. You can see that here we have the stacks that I've recently worked on, so makes them nice and easy to access. There's also some links to handy resources here. We've got lessons and tutorials, how to get up and running, how to create a Hello World app as a very first example. I'll close this down just now, and we'll have a look around the rest of the development environment. So up here you can see we have our menu bar and our toolbar. I'm on Windows, so this will look slightly different if you're on Mac, but it's basically the same structure to the development environment. So you can see here, we'll have a look at the menu bar first. We've got some standard things: open a stack, open a recent file. You've got your edit menu with your cut, copy, paste. We've then got some LiveCode specific menus here, which we'll look at in more detail as we actually start to work with LiveCode. And importantly, at the end here, we've got the help menu. This gives you access to the dictionary, the resource center, the start center, which we just saw, example stacks and resources, which are very useful when you're getting started with LiveCode. You can often find just how to do the thing that you're trying to do in some of the example stacks. We also have the user guide, which I would highly recommend. It's a very useful PDF guide to the whole of LiveCode. It explains all the things that you probably want to know very clearly, and I would recommend having this open a lot of the time while you're actually working. Here we also have our release notes for each new version of LiveCode that's released, detailing new features, new functionality. You can see here we also have the iOS release notes and the Android release notes. You can also find in the help menu our license agreement and some functions that let you manage your license, contact support should you need to. Below the menu bar we have the toolbar. This gives you access to commonly used features of LiveCode. You can see here again we have, similar to we had in the help menu, we have user samples. That's sample stacks and applications that have been created by our users and uploaded to the community. We have our tutorial section. We have our resource center, which has more tutorials, more sample stacks in it, and we also have the LiveCode dictionary. You can also see here we have some LiveCode some useful LiveCode commonly used functions and applications. Again, we'll look at these in more detail as we actually start to develop. And over here on the left-hand side, you can see we have our Tools palette. This has all the controls on it that allow you to add controls to your graphical interface of your LiveCode application. You can see here we have a variety of types of buttons. We have a push button, a default button, a checkbox, a radio button. We also have single line fields, multi-line fields, a range of scroll bars and progress bars that you can use. Once we start developing your application, you can just drag these onto your stack and they're there ready to be used. Now, before we go any further, we will just have a quick discussion of the general basic structure and event-driven methodology behind LiveCode. In the resources that you could have downloaded beforehand, or you can download after the webinar if you want to look at them, we have a diagram of the LiveCode structure. Now, the first step in creating a LiveCode application is to create the window for your application. In LiveCode, we call this a stack. And your main application will usually be your main stack. Every window you see in LiveCode is a stack. Palettes, dialog boxes, and standard windows are all stacks. Actually, the things that we looked at in the development environment, the Tools palette is a stack, the Menu Bar is a stack. Our LiveCode development environment is actually written in LiveCode itself. So all those things that you see are also stacks. So the first thing to do is create a stack. And each stack contains one or more cards. Now, you can imagine a stack as a pile of cards, like a stack of playing cards. Each stack can have a different appearance and different functionality, and by going from card to card within your stack, you can change what's being displayed on screen. So for example, if you had perhaps an address book stack, you might have one card that's an index or an overview of all the people in your address book. You would have another card that allowed you to display the full information about a person stored in your address book, and you may have another card that allowed you to add a new person to your address book. Each of those cards belongs to your stack, but each can have a different appearance and different functionality. Once you've created your stack and added some cards, you simply add objects by dragging them from the Tools palette onto the area of the card. So I think what we'll do now is we'll actually have a look at our first stack. So the first thing to do is we'll create a window. You do this by simply going to File, New Main Stack, and there you have it. That's your stack. We'll just use a stack with one card. When you create a stack, it automatically has one card. You can add more as you need them, but here we will just have one card. And I'll show you quickly how easy it is to add some controls to your stack. So for example, if we want to put a button onto our stack, that's all we do. We drag it over and we have a button. Now, as Kevin mentioned earlier, LiveCode has a compile-free workflow. You can switch between editing your stack and running your stack instantaneously. And to do that, all you need to do is switch between the Run tool here and the Edit tool. So as you can see here, we're in edit mode. We can move the button around, we can change the size of it. If we want to run our application and test it, all we do is we switch to the Run tool, and then as you can see, we can click on a button. If we had a stack, we'd switch to the Run tool, and that would allow us to type into a field whatever we wanted to type. Just remove that just now. Now, a LiveCode application is driven by user actions. LiveCode constantly watches the computer for common actions, for example, clicking on a button, typing into a field, changing cards in your stack. Whenever an event occurs, LiveCode sends a message. When writing your program, you decide what messages you want the program to respond to, and you handle those messages. By handling those messages, you can tell the application what to do when that message occurs. Any application you build in LiveCode will be based around objects, fields, buttons, scroll bars. images, whatever objects you've added to your stack. With LiveCode, you would typically create the objects of your application before writing any code. So you'd start by adding the controls you wanted to your stack, laying them out as you want them to appear, and you can then attach code to each object to respond to the events that you want it to respond to. So I think I've explained that up to a point, but the best way to see how it works is to use an example. So we'll just take the small stack that we have here. We've added a button. We check that we're in edit mode and we can select our button. Now what we want to do is add some code to that button to tell it what to do when the user clicks on it. So we have our button selected. If we now select code from our toolbar, this opens up our script editor. This is where we'll do all our coding and our editing of scripts for our LiveCode application. As you can see here, a button is automatically populated with an onMouseUp handler. This is one of the built-in LiveCode messages that gets sent when the user clicks a button. It's sent as the user releases the mouse button over the control. So in this case, when the user clicks the button, we want to say, "Hello world." So all we have to do is we use answer, "Hello world." We then apply our script. We can close the script editor, and when we click on the button, we get a dialog that says, "Hello world." Now you'll notice that I used a built-in function there, so let's use it as an example of how the dictionary works. So I used answer. So you can see here that answer is a built-in command that displays a dialog box with a message and up to 7 buttons. Now we didn't specify particularly any buttons, so we just had an OK button, but that's fine, that's all that we needed. So you can see how simple LiveCode is. We've already created a stack, added a control to it, and made it do something. Now if we wanted to make this slightly different, we could add another control to our stack. Let's stretch that out a little bit. We'll open up the code of our button again, and instead of using a dialog to say "Hello world," instead we'll put "Hello world" into field 1. Apply the script again, close the script editor, switch to run mode, and we're ready to test. Clicking the button, and it puts "Hello world" into field 1. So you can see how easy that was to switch between editing and running. Edit it. We can change this. We can say "Hello world" again. Apply our script. Just move the script editor out of the way this time. Switch to run mode. No need to compile. And you can see that updates instantly. Now we've mentioned these messages, for example mouse up, that are sent automatically by LiveCode when it notices some user interaction with the stack. Often a message that is sent to an object, for example here the mouse up button is sent to our button, is handled by that object. However, if there's not a handler on that object to deal with the message or to do something when that message is received, the message is passed up what we call the message path. Now again, in the resources for week 1 we have a diagram of the LiveCode message path. You can see here at the bottom what we've just had is an input event. It was a mouse up, which was sent to the control. Now our control handled that event, so nothing else had to happen. But if our control had not handled that event, the message would have been passed on to the card, and if the card had handled that event, if the card had had a mouse up handler on it, it would have been handled there. If not, it would have been passed up to our stack, checked for a handler, and if there was not a handler present on the stack, it would be passed up to the LiveCode engine. So again, I think a nice way of seeing how this works would be to create a stack that gives us an example of how it works. We'll clear the controls on this stack and we'll add a couple of new ones. So we'll add a multi-line field which we'll use to log our message as it gets passed up the message path. And we'll have a button which will handle our message. So again, let's open up the code for the button. It's already populated with a mouse up handler, and when this button receives the mouse up message, we'll just put something into our field to know that the button has received that message. So here we'll put mouse up, ampersand, which is a connector, and then a return character, and we'll put that after field 1. So what that'll do is it'll put mouse up and a return character after what's already in the field. Now, if I switch back to run mode and click that button, you can see that we've received that mouse up in the button, and here it is. I'm just going to change the script slightly so that we know that that mouse up was received by the button. And if we check that, you can see mouse up has been received by the button. But what happens if we didn't handle mouse up in our button? I'll comment this out for now. Click the button again, and you can see that nothing is put into the field. So, as we saw in the diagram, if the control doesn't handle the message, it gets passed up to the card. Now we can add code to our card script to handle messages. We open up the card script by going to the Object menu and opening the card script. And in here, we can add a mouse up handler to the card, and we'll just do very similarly what we did with the button. We'll put mouse up handled by card. Now when we click our button, the mouse up will be sent to the button. It's not handled by the button, so it passes up to the card. Oh, sorry, that wasn't quite right, but interestingly, I can show you something here. If you just use put and you don't give it a destination, such as a field, it's automatically put into the message box here. The message box is a useful tool, especially when you're developing. It allows you to call handlers, run one-line scripts, and as you can see here, you can use it as a debugging tool. You can put things into the message box so you can see where in a script you are. You can use it to check the value of a variable or anything else while you're debugging your scripts. If you want to use the message box at any time, you can open it up by using this message box button in the toolbar. Now I'll just correct my script here and say put mouse up handled by card and return after field 1. So now when we click on the button, you can see that the message is sent to the button doesn't handle it, so it's passed up to the card, and we see here mouse up handled by card. Now equally, if you remember from the message path diagram, if it wasn't handled by the card, it would be handled by the stack. We can open the stack script from the object menu again, and we can handle the message in exactly the same way. So on mouse up, put mouse up I'll just clear out the field here, and you can see that it's been handled by the stack. Now I'm going to comment all these handlers back in so that we can see what happens if you have a handler for the same event on all these controls. So we have a mouse up handler on our button, on our card, and on our stack. So here we click the button and we receive that the mouse up was received by the button. Because the button handled that message, the message did not get passed any further up the message path. It just stopped, it was handled, and it didn't need to go any further. Now there are occasions where you might want to handle the mouse up by the button. You might want the button to do something in particular, but you might want the card to know that a mouse up has been received, and you may want it to do something separately. In that case, what you can do is you can tell LiveCode to keep passing the message up the message path by saying pass mouse up. What happens if you pass a message is that it's handled by the control that receives the message, and it then passes it on to the next level in the message path. In this case, the button receives the message, it does something with it, but it also wants to pass the message onto the card so that the card can deal with it if it wants to. So now if we do this again, we should hopefully see that the mouse up is received by the button, and then the mouse up is also handled by the card. This allows you to use the message path and the strengths of the message path to handle events that are received by particular controls, but then maybe there's something more general that you also want to do when an event is received by any control. So you may want to do you may have a number of buttons, each of which does something different when a mouse up is received, but there may be something general that you want to happen whenever any of those buttons receives a mouse up. You could then put that on the card, pass the mouse up after it's been handled by each button, and the card could handle the more general case. Now something else that I'll show you here, we've seen the code editor, we've seen the message box. Another very useful thing is the property inspector. There's a property inspector for any control of your stack, whether it's a control such as a button or a field, whether it's the card or the stack itself. The property inspector allows you to set any number of properties related to the behavior of a control, the display of a control, and you open it up by selecting the edit mode, selecting the control you want to look at, and then clicking on the inspector button up here in the tools bar. So for example here, I've selected our button. Now our button's just called button. That's not very descriptive. So what we can do is we can open up the property inspector here and we can change the name of the button to something that explains what our button is actually going to do. So for example, we could call this test message path. And you can see when you switch back to run mode that the name of the button and the label of the button have been changed. You can see here that that doesn't quite fit on the button, so I'll switch back to edit mode and we'll stretch it out a little bit so that you can see the full name. Now having changed that doesn't change the functionality of the button at all, it just simply makes it clearer what it does. There's a number of other properties here. Again, this is something we'll look at in much more detail as the weeks go on, the different properties that you can set and what they can be used for. But for example here, there's something as simple as disabled. You can just disable a button if for some reason you don't want the user to be able to click on it. You can enable it again. You can turn off the border of a button, switch it back on. There's numerous properties to do with the behavior and display of controls. Now we've covered most of the very basic parts of LiveCode here, so I think the next thing we'll do is we'll create another stack that maybe lets us see a little bit more what LiveCode can do. I'll just close the stack, we don't want to save it, and we'll start a new one. Now for this stack, what we'll do is we'll make a stack with multiple cards this time. Our last stack just had one card. This stack will have multiple. So when you first create a stack, what you can see is card number 1. What I'm going to do here is I'm going to add a label and a button to this card. The idea of this stack is that we will see how to navigate around a stack, moving from card to card. So here the first thing I'll do is I'll add a label field. I'll open up the property inspector for the label field. I'll go to the contents pane and I will just type in here that this is card 1. This is just so we can see where in our stack we are. I'll show you here a little bit more of the power of the property inspector. We can go to text formatting. We can center our text, make it a little larger, make it bold, anything like that that we want. Now let's add another button, a button here that will allow us to navigate to another card in our stack. You can see that the property inspector for the button is open. I'm just going to change the name to next. Now let's open up the script of our button by selecting it and opening the code editor again. Now in this case, we're going to use some of the very simple English-like LiveCode coding that Kevin mentioned. What we want to do here is we just want to go to the next card. So all we have to type is go to next card. Now you might be thinking that it can't possibly be that simple, that's just what you would say, but that's often how simple LiveCode coding is. Now you'll notice there is a problem here. We've only got one card. There isn't a next card to go to yet. So what we do is we go to our object menu and we just select a new card. That adds a new card to our stack and we're ready to go to it. Now you'll see that as the new card was created, we automatically moved to the next card. So we're now on card 2. As you can see up here in brackets to help you find your way around, we have a 2. So I'm just going to do the same thing we did for the first card. We'll add a label. We'll change the contents of it to card 2 so that we know we're on card 2. We'll edit the text a little. We'll just center it, bold it, and make it slightly larger. Put that a bit more in the middle. And we will add a button to this card. Open the property inspector, and we'll call this button back. Now on the first card we wanted to go to the next card. On this card we want to go back to the first card. So we open up the script editor again, and here all we have to do is instead of going to the next card, we go to the previous card. Now let's apply our script, switch to run mode, and we'll click that button, and as you can see we go straight back to card 1. And our next button takes us to card 2, and our back button takes us to card 1. So just to show you this in a little more detail, we'll go to card 2, we'll add another card, same process. This is card 3. Just setting this up here just as we set up the other ones. We'll give this a back button, call it back, open up the code editor and go to the previous card again. Close that, I'll just apply that and we can move back. Now we have card 3, so let's add a next button to our card 2. Just close the script editor, open the property inspector, call it next, open the code editor, go to the next card, apply that, switch back to run mode, and now we can happily move all the way through our stack back and forth. And that's it. That's how easy it is to create a stack with multiple cards and allow yourself to navigate around it. Now one thing that you might have noticed that we've done here is that we've duplicated code. All our next buttons do the same thing and all our back buttons do the same thing. This is another case where we can use the power of the message path to minimize the amount of code that we have to write and to keep code that does the same thing all together in one place. Now in this case, our controls receive the mouse up messages. We could then handle that on the card, but we'd have to handle it on each card because the controls on a card only have access to the scripts of the card itself, whereas if we put our code on the stack script, all the controls on the stack, whichever card they're on, have access to them. Now we've already mentioned that there are a number of LiveCode messages that are automatically sent. For example, we had mouse up as an example. You can also write custom handlers and functions that you can call from within your stack. So let's open the stack script and we'll write ourselves 2 custom handlers. So we'll write a command called go next and another command called go back. Now these are 2 custom handlers written by us to handle behavior that happens in more than one place in our stack. To call them, they work exactly the same as built-in LiveCode messages. You simply call them from the object and they get passed up the message path as a mouse up or any other built-in message would do, and they get handled as soon as there is a handler that can deal with them. So our go next will just do exactly what our buttons did. It'll go to next card, and our go back will just do what all our back buttons did. It will go to the previous card. Now what we have to do is go back and we have to change our buttons to call these two custom handlers instead of manually being scripted. So we'll change our next button. I'll just show you this is another way you can edit the script editor. You can enter the script editor, you can right click or command click on a button and you can edit the script here. So instead of going to the next card, we'll just go next, apply that, close our script editor. And you can see as soon as we click on it, what happens is it calls that go next handler. It gets passed from the button to the card. The card doesn't handle it, so it gets passed up to the stack, which handles it. We'll now edit these two buttons. So this one will just go back, and this one will go next. Then we'll go to card 3 and we'll edit the back button here. And hopefully when we switch to run mode, we should be able to see that our stack behaves exactly the same as it did before. It allows us to move through. Now this is a very simple example and maybe it doesn't particularly show why you would do something like this, but if I open up the stack script again, we can put in an extra piece of code in here. For example, user answer dialog again. So you can give some feedback to your user just so that they know what's happening. So for example, going to the next card, and we can do the same when we're going back. Let's apply our script, move that out of the way, and you can see here we're going to the next card, and we go to the next card. We go to the previous card, and we go to the previous card. Again, it's a very simple example, but you can see that we only had to change the script here in one place, rather than having to go back in when we wanted to make a change and edit the behavior of each button that performed those procedures. Now, the general rule for writing your own custom handlers is to put them as far up the message path as they need to be, but no higher. So if you write a handler that's used by multiple controls but only on one card, then put it on the card. The stack doesn't need to know about it. But if you have a handler that's used by multiple controls on multiple cards, put it on the stack script, then all the controls anywhere in the stack have access to that handler. So just to repeat that, the general rule is to put your custom handlers as high up the message path as they need to be, but no higher. So that's another very simple example. It shows you how to navigate around a stack. Hopefully that gives you a good idea of how to maybe get started with some LiveCode applications. Hopefully, as I mentioned earlier, the user guide is a really useful resource. Everything we've discussed this week is gone into in more detail in the user guide, whether it's the code editor and its different features and how it works, the message box and what you can use it for, how cards and stacks are structured and used and saved within LiveCode. So I'd recommend having a look at those particular sections in the user guide and any other sections early on that will help you get to grips with the basics of LiveCode and hopefully get some ideas of what you can do.